Okay, what I wanted to do today was go over some of the hyperbolic trig functions and derive a few of the common identities that we'll use. So to start with what we have here, we just have the definition of sinh and cosh of x. So they're very similar, of course. The only difference between these two is the minus sign and plus sign between them. And there is a nice relationship between sinh and cosh that I went over in another video. What I can do is if we just split this up and write it a little bit differently, split it into two fractions for each of these. So I can write this like this, splitting it on the minus sign, and then doing the same thing with cosh. I can write it like this and add these two fractions. And then here, if we want to get an expression for sinh of x plus cosh of x, we can just add these together. And what's going to happen is these second terms cancel. We have two of these, so we're going to have 2 times e to the x over 2. This cancels, and this sinh x plus cosh x is just e to the x. And then doing something really similar, if we just subtract these, but starting with cosh, so cosh x minus sinh x. So what's going to happen is these first terms are going to cancel, and we're going to get 2 of the second term. So we're going to get 2 of e to the minus x over 2, but this cancels. And so this expression is just e to the minus x. Now another nice thing we can do with just sinh and cosh is take the derivative. So I'll just start with cosh. If I take the derivative of cosh of x with respect to x, so using the definition in this form, if we take the derivative of 1/2 e to the x, we just get 1/2 e to the x. And then here, if we take the derivative of this, we get minus e minus x over 2. But this here, we can put it back in this form and write it as e to the x minus e to the minus x over 2. And that's actually our definition for just sinh of x. And then we can do basically the exact same thing for sinh of x, taking that derivative with respect to x, broken up this way. The derivative of the first term, again, is e to the x over 2. Taking the derivative of the second one, the minus comes out, and now we get plus e minus x over 2. But then again, we could put this together or leave it in this form, but this here is going to be the same thing as cosh of x. So these things are the derivatives of each other. Now something else I can do with these two expressions here is if we just multiply these together. So if we multiply cosh x minus sinh x, and we multiply that times this one, I'll just change the order and write it as cosh x plus sinh x. Well, then this expression here is just e to the minus x, and this expression here, this is just e to the x. So when we distribute this all out here, we get a difference of 2 squares, so we're going to have cosh squared x minus sinh squared x. And here, multiplying e to the x times e to the minus x, well then we add the exponents and we get just e to the 0, but e to the 0 is just 1. And so that's how we get this useful identity. Cosh squared x minus sinh squared x is just equal to 1. Next, what I want to do is let's just look at what happens when we multiply these two. When we take sinh of x and we multiply it times cosh of x, well, I use these two definitions here. We have a half on both of them. So we multiply it together, we can have a 1/4 that we take out front. And then what we're doing, let's just write, we'll have e to the x minus e minus x. And then we're multiplying that times this, which is just e to the x plus e minus x. So then we'll distribute everything out. We'll bring down our 1/4. E to the x times e to the x gives me e to the 2x. This inner term, e to the x times e to the minus x, that's a 1, so we'll minus 1 here. But then here, e to the x times e to the minus x, that's a plus 1. Then multiplying the last two terms, this is going to give me minus e minus 2x. But then the 1's are going to cancel right here. And then I can take this 1/4 and split it up as 1/2 times 1/2. And so what I'll do is take 1/2 and distribute it inside the parentheses and put this all together. So we end up with e to the 2x minus e minus 2x. And that 1/2 we'll put right here. But now this thing right here, you might recognize this is really similar to sinh, but with just a different input. We have 2x for our input. So this here, this is actually the same thing as sinh of 2x. So to clarify this, we're going to have 1/2 sinh 2x here. But now to get rid of this 1/2, I can just multiply by a 2 here. Of course, I have to multiply by 2 everywhere, but we're not really interested in this. I can just multiply 2 here. And then what's going to happen is 2 is going to cancel with 1/2. And so we have this identity here that sinh of 2x is the same thing as this thing, 2 sinh x cosh x. And of course, this one's really easy to remember because this double angle formula works the same way as the formula for regular sine. Sine of 2x is the same thing as 2 sine x cos x. Okay, next what I want to do is just get an expression for sinh squared x. And again, we'll just use this and square everything out. But we'll take this, I'll take the 1/2 out front so I can bring a 1/4 out front here. and then we can just kind of distribute. We're multiplying out e to the x minus e minus x, and I'll just write it out twice because we're going to have to multiply this out. So then we'll just distribute everything out here. So this is going to become, this first piece is going to be e to the 2x. This here is going to give me a minus 1. This here is going to give me another minus 1. For the last terms, we're going to get plus e minus 2x. This is going to become minus 2. I'll do what we did in the previous example and distribute in. We'll split up this 1/4 as 1/2 times 1/2, so that way I can multiply in a 1/2. So then we'll put these two pieces together. So I'll write this as e2x plus e minus 2x over this 1/2 that we distribute in, but then we'll also have to distribute into this minus 2, and that'll become a minus 1. But like what we did last time, this, you'll notice this is the same thing. This is like cosh with our input of 2x. This is actually going to be cosh 2x. So for my expression for sinh squared of x, I can write this as half cosh 2x, and then distributing in half to minus 1, I can write this as minus 1/2. Next, we'll do something really similar, but we'll do it for cosh squared of x. So again, we'll take the 1/2 out front and square it. So we'll have our 1/4 here, and then we're going to need to distribute out everything else. So just multiplying this out the same way we did before. This first one, we're going to get here, this is going to be e2x. This here is going to become a 1, and then this here is going to be 1. So I'm going to put those together. I'll write this as plus 2 here. And then putting these two terms together, this is going to be plus e minus 2x. Doing the same kind of thing, splitting 1/4 into 1/2 times 1/2, we'll have 1/2 out front. And then this first part, putting this together, this is going to give me e2x plus e minus 2x over 2. And then we distribute it at 1/2 to the 2, and we just get a plus 1 here. But again, this is going to be cosh of 2x, so I can write this thing as 1/2 cosh 2x, distributing half to 1, this is going to be plus 1/2. And this is going to be our power reduction for cosh squared of x. Okay, now just a couple of things before we finish it off. Using these two formulas here, if we subtract these, if we do cosh squared of x minus sinh squared of x, well, this is something we just did earlier in the video, but just using this, doing it this way, what's going to happen is the 1/2 cosh 2x, we have them in both these, so when we subtract, those cancel, we end up here, we get 1/2 minus times minus 1/2 is plus, and so this is 1. This is the same thing we got earlier. So nothing new here, right? But if we actually change this to a plus sign, this gives us another identity, because when you add these two together, we get 2 times 1/2 cosh of 2x, and then we have plus 1/2 minus 1/2, but that's just going to be 0. We don't care about that. We can take the 2 and cancel with 1/2, and we have this identity that cosh squared x plus sinh squared x is just the same thing as cosh of 2x. Okay, so there you have it. I think we covered most of the basic trig identities for the hyperbolic trig functions. In the next video, what I'll do is derive all the half angle formulas. Thanks everyone for watching. Have a good day.